Welcome to video 8 of Tasks in Scala. Today we're going to be talking about booleans, relational operators, and filtering. And the task that you will be doing after the video is, given a list of sandwiches with their bread, topping, and price, determine. So there are 3 questions here. How many sandwiches cost more than €1? What sandwiches were using white bread? And did some sandwiches have more than one topping? Very important questions. Let's get started with booleans. A boolean is a type that can have the value true or false. So for example, I'm going to create a boolean that's called Ollie is cat of type boolean, and I'm going to put it to true because that is indeed the case. And another boolean, it is cold. Well, I'm going to put that to false because it's quite warm over here. And just print both of them so you can see it. It is cold. True and false. Now over here, I just stated that it is cold is false. But what if we want to determine whether it is cold or not depending on the temperature? So I'm creating a value temperature that is a double, and it's 28.9 degrees. And then I'm going to create it is cold again, which is a boolean. And then I'm going to say, well, it is cold when the temperature is below 12 degrees, for example. So then here I can put the test, temperature below 12. I put a question mark in my head. This will test whether temperature smaller than 12 is going to be either true or false. And we call this a relational operator. Relational operator. So in this case, it's testing whether A is smaller than B. So A, you just fill in something. Temperature smaller than 12. This is how you write it. And you also have the opposite, that is A greater than B. And you write it like this. But I'm getting ahead of myself. Let's first check whether this is correct. It is cold again. Print this. And it prints false. I'm actually going to comment out the other two so we don't get confused about the result. False. So it is cold again is false, which is correct because 28.9 is not smaller than 12. Okay, now we can also try the opposite. I'm going to comment this one out again so we don't get confused. For example, it is hot, which is going to be a boolean. And in this case, we're going to say that it's hot when the temperature is above 25. So I'm going to write temperature above 25. This part will become either true or false. And let's just print it to see what the outcome is. It is hot is true because 28.9 is larger than 25. Great, I want to show you some more relational operators, but first we're going to need a case class for that. Case class animal, which has a name and a type. I don't know if I said this before, but on this side, I'm writing type animal and not just type, because as you can see, when I write type, the color changes. That is because it is a keyword in Scala, so you cannot use it. So I'm writing type animal. And then I'm going to create a class instance that is an object, which is Ollie. And Ollie is a cat. And now we can, for example, test whether Ollie is a cat, because over here I just stated Ollie is cat is true. But now we actually have some information and we can just dynamically decide whether Ollie is a cat or not. Cat again, which is going to be a boolean, and this time I am going to take out the type of Ollie. And then I'm going to check whether it's a cat. And I do that with this double equal sign. So this is basically asking, is the type animal of the object Ollie equals to cat? So this will be either true or false. let's print this. Oli is cat. Again, I'm going to comment out the other print so I don't get confused. And the result is true because Oli is indeed a cat. Now we could also try Oli is dog. And then we do the same type of test, only this time we check whether it is a dog. Let's print this one. Oli is dog. Oh, I'm going to comment out the other one. And that is false because Oli is a cat according to the information that we gave. Okay, so this is basically the test A equals B, and you write it A equals B. Now there's also the opposite of this, and that would be A not equal to B. And we would write it like this, exclamation mark, and then the equal sign. I'm writing it apart now, but you shouldn't write it apart. Okay, exclamation mark, equal sign. So look at what Scala makes of it. I do the exclamation mark and then the equal sign. It already makes the symbol right away of not equal to. So I will just write here that you have to write the exclamation mark and the equal sign together. I don't know how I can make it clearer. I hope that you get it. So for example, we can test whether Elena's name and Susie's name are the same. So we would say, well, they are different names if Elena does not equal Susie, right? Okay, once again, commenting out the line over there and printing the different names. Oh, let's see. True. So it is true that Elena does not equal Susie. Wonderful. Why is this useful? Why, oh why? Well, we can use it in decision making, and we're going to see that right now. We're going to do that with if statements. For example, we want to tell the public whether it is hot or not. Let's just write that down. We want to tell the public whether it is hot, wow, or not. I'm gonna create a function, announce hot or not. This must be one of the funniest function names that I've come up with. And we're gonna test that with the current temperature, which is an int. And what we're gonna do is check whether the temperature is above 25, and then we wanna print that it is hot. So we do that with the if check. If current temperature above 25, then we want to print it is hot. And if not, else we want to print it is not hot. Let's try this. Announce hot or not. For example, with 15 degrees. I spelled it wrong. This is not a very smart name for a definition. It is not hot with 15 degrees. I agree with that. Now let's check for 30 degrees. It is hot. And now for 25 degrees, it is not hot. Because 25 is not larger than 25. 25 is equals to 25, right? Okay, we're gonna expand on this a little. Once again, commenting out the printing stuff so we don't get confused. This time I'm creating a function that's called announce weather info. It uses the current temperature, which is an int. And we start the same way. We say, well, still, if the current temperature is above 25, then we want to print that it is hot because it's definitely the case. Else, if the temperature is still above 15, then we're going to say it is okay. And otherwise, we're just going to print that it's cold. truth has been spoken, okay? Let's try this. So it is announce weather info for 10 degrees. It is cold. For 20 degrees, it is okay, because for the 20 degrees, it is not larger than 25, so it doesn't go to this part, but it is larger than 15, so it goes to this part of the code. And then if it is 30 degrees, it is simply hot. The if statement, we can also do it as a one-liner. For example, what time is it? We're gonna say if the temperature is above 20 degrees, it is ice cream time, and otherwise it is just sitting around time. Let's print this to see what it gives us. What time is it? Sorry for the background noises today, it is especially noisy. This will print to ice cream time. So you can see that you can also do a very simple one-liner. Okay, now we're going to use this new obtained knowledge to work on lists, and we do that with filtering on lists. For example, I have a list with ice cream flavors. Strawberry, chocolate, lemon, melon, and banana. Delicious. Let's say that I want to grab all flavors that have less than 6 letters in their word. So what would I do? I'm gonna copy this right here. I would want to take strawberry, take the size, and then check whether it's smaller than 6. So this is the test that I would do, right? And then I would move on to chocolate, take the size, and test whether it's smaller than 6, go on to lemon, etc., etc. And I would go through the whole list, and for each of the flavor for which this is true, I would want to grab it. You want to grab all elements from the list that test true. You would write it down like this. You take a flavor, and then from the flavor we take the size, and then we want to check whether it is smaller than 6. So this part becomes true or false. And what we want is that for all elements that this results to true, we want to grab them and put them in a list. And that is exactly what filtering does for us. So we're going to create a list that's called short flavors. And for that we take the list of ice cream flavors. We're going to filter this list, and we only want to grab all of the flavors that have the size smaller than 6. So we're going to write it like this, and let's print it. Print short flavors. This results to the list of lemon and melon, because in this list of flavors, those are the only 2 that have less than 6 letters. So that's how the filter function works. Let's see another example. Let's say I want to know how many excellent reviews did we get from 1 to 3 star reviews. I have a list here with the reviews. In the beginning it didn't go so well, then we picked it up a little, and then we went down and up, and it was a roller coaster. So here we have a collection of stars that we received. Now, I want to grab all the excellent reviews. An excellent review, I would say, is 3 stars. So we're gonna create a list of excellent reviews, which means I'm gonna take the reviews list and filter out all the reviews that are equal to 3. Let's print this. Excellent review. Yes. This gives us a list with 4 3s, which is quite correct if I look at the original list that we had. But the question is, how many excellent reviews did we get? So if you want to know that, you actually have to go one step further, and I'm going to create a new value for that. Number of excellent reviews is the size of this list. So let's print that. Number of excellent reviews, 4. We received 4 3 stars. I would say that's not bad. Okay, now let's check out some filtering on objects. For that, I'm going to create a new case class, which is called person. And a person has a name and an age. And I'm going to create 3 people. I'm actually going to copy them. And then I'm going to create a list of people. So of the type list person, which contains Anna, Peter, and Valerie. Okay, so this is what we start with. Let's just print the people list. Print people. And I don't know if I mentioned this before. This is printed very nicely because we are working with a case class. So that is another nice perk of a case class. Okay, just a small interlude. Let's say I want to make a list of all the people with short names. I would do that as follows. I take the people list and then I filter every person for which the name size is smaller than 5. Let's print this result. People with short names. Names. And that is only Anna, because Anna has 4 letters and Peter, for example, is already 5 letters. So we can just filter like this. Another thing we could do is, for example, people over 30. Then we take the people list and we filter on a person, its age, and we say, well, over 30, that means greater than 30. Let's print this list. Priontenel, people over 30. Peter's 35 and Valerie's 42, so that is quite correct. Okay, now we're going to look at an example that's similar to what you will do after this class. I'm going to copy it here. Given a list of ice creams, get information about the ice cream consumption. This is also very important, right? First question, what ice creams were consumed on Saturday? Second, how many ice creams cost more than €1? And third, did some ice creams have more than one flavor? This is all very important to know. The first thing we're going to do is create a case class called ice cream, which has a day, which is a string, and then flavors, which is a list of strings, because of course I can opt for multiple flavors. And then finally, the ice cream also has a price. I already prepared 3 ice creams here. We have an ice cream on Monday that was chocolate and vanilla, and it cost $1.80. We had an ice cream on Tuesday, which had only the flavor lemon and cost 95 cents. And then the third ice cream, we ate it on Saturday, or maybe I ate it on Saturday, because this is an amazing ice cream. Chocolate, banana, and cookie. I mean, come on. And it was $2.50. Let's just create first the list ice creams, which is of the type list of ice cream. And we just simply create the list of ice cream 1, ice cream 2, and ice cream 3. Let's print it. Wow, why did I type a capital letter all of a sudden? Great. So we have a list with 3 ice creams over here. Now we're going to start with question number 1. What ice creams were consumed on Saturday? So we're going to create a list that is Saturday ice creams. And what we're going to do is filter the ice creams from our ice cream list of which the day equals Saturday. We take the ice creams, filter. We're going to pick out the ice cream of which the day equals Saturday. Let's print this. Saturday ice creams. Oh, Datterday. It's definitely not Datterday. And the list of ice creams on Saturday is a list with just one ice cream, because indeed we only had one ice cream on Saturday. Second question, how many ice creams cost more than €1? First, I'm going to create a list that's called over €1, which is going to contain all the ice creams that are over €1. And I'm lazy, so instead of ice cream, I'm just going to write I. And then I'm going to check on the price whether it is larger than 1. Let's print this. Print line over €1. And this gives us the list with the ice cream that I had on Monday and the ice cream that I had on Saturday, because they were both above €1. But the question was, how many ice creams cost more than €1? So I'm going to create a new value that's number over €1. So this is going to count the amount of ice creams that were over €1. And I'm just gonna take the list that I made before and take the size. Number over €1. How many ice creams cost more than €1? 2. Third and final question. Did some ice creams have more than one flavor? Let's create a list of all the ice creams that have several flavors. We iterate over the ice creams list and we filter out all the ice creams for which the size of their flavor list is larger than 1. Okay, let's print this. Several flavors. Okay, now we have a list with the ice cream I had on Monday, which was chocolate and vanilla, and then the mega ice cream I had on Saturday with 3 flavors. And the question was, did some ice creams have more than one flavor? And we can test that looking at whether this is empty or non-empty. So we can create a Boolean that's had ice creams with several flavors. That's quite a long name, so this is a Boolean. And we're going to check that looking at the list that we just made. And we're going to say, well, was that list not empty? And in Scala, we use the word non-empty. Let's print this. I'm going to copy this because it's so long. Did some ice creams have more than one flavor? True. So that means yes. That's all for today. So we have looked at Booleans, relational operators, and filtering. A Boolean is just a type with true or false. Then we saw a few relational operators, which are basically testing the relation between two values. And then we use this kind of testing in the if-else statement, of which we saw the more expansive version, but also the simple one-liner. The big icing on the cake today was the filtering on lists. Let's look at the task one more time. Given a list of sandwiches with their bread, topping, and price, you're going to determine these 3 fancy questions. How many sandwiches cost more than €1? What sandwiches were using white bread? Did some sandwiches have more than one topping? So you are going to create a case class for sandwich. Then you're gonna create at least 3 class instances of a sandwich, so you will have multiple sandwiches. Then create a list of all the sandwiches together, and with that you're going to answer the 3 questions, and you have to give answer to each question in a single value, just like we did in the last assignment. So for example, if we look at this part, did some ice creams have more than one flavor, then the actual answer is this Boolean. Okay, this was just a step in between and we just printed it for our own convenience, but the actual answer is this Boolean. Okay, good luck, and I'll see you in the next video.